So there's a lot of important information in this lesson with different kinds of symmetry. So I thought it would be best if you learned from a video. I walked around the room to help, and that way you always have a record of what I'm saying and you can go back and watch it again and rewind and whatnot. So symmetry occurs when one shape becomes exactly like another, such as you fold something, you flip it, you slide it, or you turn it. What does it mean to carry a shape onto itself? And carry is another way to say map. So what does it mean to map a shape onto itself? Let's think about it like this. Using transformations, move a shape so that all sides and angles sort of line up again. All right, so write that down. Pause the video right here. Write that definition and I'll show you an example. The example, I have to set it up here, but if this was an equilateral triangle and then I use the transformation such as a rotation and I rotated it so it lined up with itself again, that would be a form of symmetry. You could also fold something in half so it lines up. That's another way to do it. Now that we have the definition done, write down that there's three different kinds of symmetry. There's line symmetry, there's rotational symmetry, and there's point symmetry. And we'll cover all three of them. Anytime you need to write something down, pause the video. I'm going to show you an example of line symmetry with this. I guess an isosceles triangle is a good example for line symmetry because I could draw a line down the middle, and it's basically the place you would fold it to have this line up with the other side. So you would fold it right down that line. The fold is a line of symmetry. Rotational symmetry, I'm going to go back to an equilateral triangle like this. Rotational symmetry is if that's kind of sitting on the bottom now, I could turn it 60 degrees and it looks exactly the same. I didn't fold it, I turned it. So it's rotational symmetry. I could turn it again 60 degrees. And if I drew that perfectly, it would line up again. So instead of folding it like I did in the one above, you're turning it to make it look the same, and that's called rotational symmetry. Point symmetry has a lot to do with rotational symmetry, but point symmetry has a point, think about it sort of like in the middle, where if I spun it, if I put a thumbtack right where that pink dot was, and I spun it exactly 180 degrees, does it look exactly the same upside down? The letter N looks exactly the same upside down as it does right side up. So if you can turn it upside down 180 and it looks exactly the same, then the shape says it has point symmetry. Okay, if you missed any of that, make sure you go back, watch it again. Don't just write what I'm saying, but pause and make sure you're understanding it. We'll take these one at a time now. Line symmetry. It's also somewhat of a reflection. When two halves of a figure mirror each other across a line. So you could have vertical line symmetry, such as the letter A. If I drew a vertical line down the middle, if drawn perfectly, that would be an example of line symmetry that's vertical. The letter B is an example of horizontal line symmetry, because if I drew a line this way and folded it on that line, the bottom of the B, if the B was perfectly symmetrical, would fold up or down right onto itself. So it almost looked like two letter Ds on top of each other. And when they fold onto one another through a horizontal line. And then there are some shapes or letters, I'm just using letters because they're good examples, that have both horizontal and vertical line symmetry, and sometimes even more. But here I could fold the H this way, and it would line up perfectly, and I could also fold the H that way, and it would line up perfectly. So that has both horizontal and vertical line symmetry. That takes us to the bottom of page 15, so I want you to work on page 16 on your own and see if you can draw all the lines of symmetry for all those shapes. For example, in number 24, how many lines of symmetry does this block A have? There's really nowhere else I can draw a line other than down the middle. So I drew it, and I'm going to say this has one line of symmetry. So try that for all the other ones. Make sure to stop the video when you're done with page 16 and don't watch any more until we're back together. Okay, now for rotational symmetry, the second type we'll cover. A figure has rotational symmetry if the image under a rotation through any angle maps it onto itself. And that's between 0 and 360, which is one spin around. Now, if that definition seems confusing, just watch this. I had two shapes here. We'll take them one at a time. Look at the square first. As I rotate this, I can rotate it and it looks the same after a 90-degree turn. I did a quarter turn, which is 90 degrees, and it looks exactly the same. That's rotational symmetry. I do it again, 90 degrees. That's the second time it looks the same. I can do it again. That's the third time it looks the same. There are 4 different positions that this has rotational symmetry. The octagon, 8 sides, octagon. Same thing, except just what you would think, there are 8 places that it looks the same, and you don't have to turn it as far. Instead of turning it 90 degrees, you only have to turn it half that much because it has twice as many sides. So 45 degrees, the same. 45 degrees, the same. 45 degrees, the same. And over. There'll be 8 different positions where that looks exactly the same. That is rotational symmetry. And there'll be a point that you sort of pin it in and you spin from that point. Now the angle of rotation we sort of covered up there when we did the square and the octagon. The square had an angle of rotation of 90 and the octagon had an angle of rotation of 45. And what that means is it's the smallest angle that you can turn something where it will line up the same way again. So if you go back to the picture up here, the angle of rotation, the smallest angle, I have to go how far until it looks the same again? 90. So the angle of rotation is 90 for a square. The octagon, how far did I have to turn it? Just 45 degrees. So the angle of rotation for this octagon will be 45 degrees before it looks exactly the same again. And order of rotation, the order is just how many positions will it be in within one full turn where it looks exactly the same, and that number is the order. So let's go back to our original example. We already said this before. There are how many positions with a square? 1, 2, 3, 4. So we say that the order is 4. Yes, we could keep going over and over and over, but we do it within one full 360 spin. You only count how many within one full turn. How many times does it look exactly the same? With the octagon, there are 1, 2, 3, 4, 5, 6, 7, 8. Because there are 8 sides, it's an easy one to see. So the order for the octagon would be 8. There are 8 positions where that octagon can look exactly the same when you spin it within one full turn. One important thing to cover here at the very bottom, the order of 1 means there's no rotational symmetry. You'll never have 0 because you can always see it once. So if you had a really goofy shape that only looked the same in one position and it didn't look the same until you turned it all the way around again, 360, that's considered order 1. Now let's actually try this with these 8 examples here. There's some math behind the relationship between order and angle. So let's look at this one. This is sort of a square, just turned on its side. And there are 4 positions, just like we did before. So the order would be 4. There's 1, 2, looks the same, 3, looks the same, 4. And then if we did it again, we'd be back to where we started. So the order is 4. Now how do you find out the angle of rotation if it's not always an easy one? You always start with 360 and then you divide it by the order. So 360 divided by 4 is 90. So the angle is 90. It's always 360 divided by the order is your angle of rotation. Then there's this green H. There's 1 position, and it's not until that it happens again. So there's really only 2, because the next one would be back to where we started. So the order is 2. 360 divided by 2 is an angle of 180. The next one, I just traced over this so I could spin it, but looks like a recycling symbol. If you turn this 1 time, 2 times, 3 times, there are 3 positions where it looks exactly the same before you get to back where you started. So 3 for order, 360 divided by 3 would be an angle of rotation of 120 degrees. Every 120 it looked exactly the same. This is one of those strange cases. A horse sign of some sort. When I start to spin this, does it ever look exactly the same again? Not until I get all the way back to the beginning. So you never say 0 because we're looking at it right now. That's at least 1. So if it doesn't happen until you go all the way around a full time, you say order 1. So the angle is a full 360 divided by 1, which is, it takes 360 to get back to where it started. This double up and down triangle looks like an elevator button. There's this position, and there's this position, and that's it. So the order is 2. 360 divided by 2 is an angle of 180. This domino-looking logo, it's very symmetrical, and it's very similar to the first one. There's 1, 2, 3, 4 places where it looks exactly the same. 360 divided by 4 is an angle of 90. And then this flowerish thing, it's very similar to an octagon. There are, I'm going to mark it, we'll start right there. 1, 2, 3, 4, 5, 6, 7, 8 different places before we get back to the original top. So the order is 8. 360 divided by 8 is an angle of 45. And this last one, first glance it might look like it has some symmetry, but because of the black box sort of at the bottom, it really doesn't. When you start to turn this, it doesn't look the same again until you get all the way back to the very beginning, which means it has an order of only 1 and you had to turn it a full 360 before it looked the same again. So if you have any questions on assignment number 13, which is page 18, go back and look at the notes, see what we did, try to figure out from the notes which problems match up the same. A lot of them are similar, they even look similar shapes, so you should be able to match them up and figure out how to do numbers 45 down to 59.